Why does iron stick to a magnet? And more importantly, why do some materials become magnets at all? Over the past century, physicists have tried to answer this question, moving from simple classical ideas to deep quantum theory. This is the story of ferromagnetism. In 1907, Pierre Weiss proposed a bold idea. He suggested that inside a ferromagnetic material, each atomic magnetic moment experiences an internal field, created by its neighboring atoms. This became known as the molecular field. It successfully explains spontaneous magnetization, the ability of a material to become magnetic even without an external field. But there was a problem. Weiss could not explain where this internal field actually comes from. Soon after, Pierre Curie introduced another key concept. He showed that above a certain temperature, known as the Curie temperature, magnetism disappears. Thermal motion becomes strong enough to destroy the alignment of magnetic moments. This revealed that ferromagnetism is not just a property, it is a phase of matter. The real breakthrough came with quantum mechanics. Werner Heisenberg discovered that ferromagnetism arises from something called the exchange interaction. This is not a classical force. Instead, it emerges from the quantum nature of electrons and the symmetry of their wave functions. It is this interaction that makes spins align with each other. To understand these systems better, physicists introduced simplified models. One of the most important is the Ising Model. In this model, each spin can point either up or down. Despite its simplicity, it captures the essence of phase transitions and collective behavior. At low temperatures, another fascinating phenomenon appears. Disturbances in spin alignment propagate like waves through the material. These are called spin waves. When quantized, they are known as Magnons. Today, our understanding of ferromagnetism goes even deeper. In real materials, electrons move through energy bands. Their interactions are described using quantum many-body physics and band theory. Models like the Stoner theory explain ferromagnetism in metals such as iron. From Weiss's simple molecular field to the quantum mechanics of exchange interactions, ferromagnetism shows how physics evolves, from intuition to fundamental understanding. And even today, the story is not over.